Hello, guys. Good morning. Good morning to all of you. Welcome to Physics of English. Once again, we are here with another lecture. So, without any further ado, let's start. Good morning. Okay, so I think audio, video, everything is all right. So, we are directly coming into the point. Today's lecture title is Vector Analysis Part 2. So in the last two lectures we covered dimension analysis and we started vector analysis. So we have done the introduction part of the vector analysis. Today in this part we'll be going forward one step ahead. And guys, if you have not downloaded our Physics Hub application, you can download it from the Play Store by searching this name, or you can also scan this QR code to get the application. And before I continue, let me tell you guys, if you are appearing for GATE examination, you can go for this GATE 2024 physics mock test series. Basically full test series is available, and as well as only full length mock tests are also available. This mock test has complete and detailed solution. So in a separate PDF form you will be given the solutions, and you can attempt the test in any device, on mobile, on desktop, on tablet, everywhere you can attempt the test. So you can purchase this. The link of everything is given in the description. So without any further ado, let's start. So in the last class we started discussing about gradient, divergence and curl, and we covered the gradient part. Let's start with the divergence. These things are very simple, but as we are doing this course from the very beginning, so this is equally helpful for a beginner as well as an advanced learner. So let's start with today's topic. So we'll start with divergence. What is the meaning of this term divergence? Divergence basically literally means that to expand, right? So the measure of divergence gives you how much some vector field is expanding. This is the literal meaning of divergence. Now let's try to define it mathematically. Okay. So mathematically, how do you define this particular thing? So divergence of a continuous differentiable vector point function. What does this term continuous meaning here? Continuously differentiable, it is like if you take one derivative, first derivative, it will exist. You take second derivative, it will also exist. You take third derivative, that will also exist. So it is continuously differentiable. So divergence is defined for a vector, and what you get ultimately, you get a scalar. Okay. So divergence of a continuous differentiable vector point function V is specified in a vector field. So we are basically defined it for a vector, right? This you have to remember. This definition are very trivial, but we have to do it. Divergence of V. So here the grad operator we already know, del x I cap plus del y j cap del z k cap, and V is a vector function. So it will have three components: Vx I cap, Vy j cap, Vz k cap. So for the time being we are doing it for the Cartesian coordinate, and in the upcoming lectures we will also look this expression of divergence in different coordinate system like spherical polar coordinate, cylindrical polar coordinate. So you see I cap and this I cap, so that makes one del Vx upon del x plus del Vy upon del y plus del Vz upon del z. So you can see this is purely a scalar quantity. So divergence of a vector function is a scalar function. Okay, now let's quickly talk about the physical interpretation. Physical interpretation is quite obvious from its name. Physical interpretation, you can predict from its name. It basically represents gives you a measure like how much the vector field is expanding. We'll also take the help of some picture to understand this thing. For the timing, let's write it that divergence at any point, divergence is defined at any point, divergence of V at any point, let's take an arbitrary point P whose coordinate is x, y, z, is defined as the outward flow. Okay, it is defined as the outward flow or flux, outward flux of the vector field V, per unit volume enclosed by the point, enclosed by an infinitesimal closed surface surrounding at P. You can understand it in this way. You have a vector field, so any point, and you have to consider the outward flux over some infinitesimal closed surface surrounding the point P. So this is the physical interpretation of divergence. Look, you can get different values of this divergence. You can get the value of the divergence, you can get it to be positive, you can get it to be negative, you can get it to be 0. So divergence is only giving you the magnitude, the value. It doesn't give you the direction. It only gives you the value. It doesn't give you the direction. It doesn't give you the direction of the vector field. So that is why this divergence is a scalar quantity. They are very simple thing. I hope you understood. Let's take an example to visualize this thing in more detail. Look at this picture. Okay, this is an example of the vector field. Okay, this is drawn based on some vector field, maybe with some mathematical software. These vector fields are shown. As you can see, the arrows represents maybe the magnitude. As you can see, it is expanding. So it is an outward flux of the vector field. Imagine that the vector field F pictured here gives a velocity of some fluid. It appears that the fluid is exploding outward from the origin. Okay, so in the at the origin it is originating and it is expanding outward. This expansion of fluid flowing with velocity v is captured by the divergence of f, which we denote divergence of f. And this divergence is positive since the flow is expanding. So I give you three cases in the last slide, that it may be positive, it may be negative, or it may be 0. So based on this, it has got three names. When it is less than 0, divergence is less than 0, it means the flux are coming towards a particular point. Okay, that you have to keep in mind. When the divergence is negative, it means the flux is incoming flux, that is called sink field. And when it is positive, it means the flux are going outward like this. This is called source field. And when the flux are not either expanding, neither expanding nor compressing, then that case is called solenoidal. So sometimes you may be given some question like for what value, maybe B is given, some vector function is given in terms of some unknown quantities, and you may be asked for what value of that unknown quantity the vector field will be a solenoidal field. Then we have to employ this condition. This condition is particularly the most important condition among these three. And with a practical example also you can understand this divergence concept. Let's say we have a water tap, water is coming, so where the water is just falling down. So from that you can understand that if you look at the direction, let's take red color. So here at this position the flow of water is outward. So here this is a source field, so grad V is greater than 0. Okay, now you see in the sink, why the name sink? Because in the sink you see water flow is going inward through this sink and going out. So that is why here grad divergence of V is less than 0, and that is why it is called sink field. And if you go away from this water flow, here you see, so this kind of thing, neither expanding nor compressing. So this is the example of solenoidal. So with a real life picture you can understand this phenomena beautifully. Now there are some formula related to this divergence which you should note. Two formula I will be giving you. Like if you consider the divergence of the sum of two vector functions, let's say one vector is u, another vector function is v. So divergence of u plus v, this will be distributive in nature. So divergence of u plus the divergence of v. On the other hand, another formula is there which you should note, that if you consider the divergence of some vector function with a constant multiplier, let's say alpha. Alpha is a scalar quantity or constant. Then what will be its value? Let's say this the usual notation is u, small u. U is a scalar. This u is a scalar here. So this will be gradient of u and the divergence with v, and dot product with v, plus u times divergence of v. So these two formula you need to keep in mind regarding the divergence. So I think you have understood divergence pretty well. If you have any question you can ask. Let me give you an idea about the curl after that. Curl is also very simple thing. Curl, what is the literal meaning of curl? Curl means something which is rotating. So what does curl represent? Curl represents the rotation of the vector field. Curl is also defined for a vector. So let's define curl of a vector field. How to define? So as usual, curl of a continuous differentiable vector at any point. Okay, curl of a continuous vector point function V is defined as, how do you define this? Curl of V, right? So this is Nebula operator, del x I cap plus del y j cap plus del z k cap, and this is Vx I cap, Vy j cap plus Vz k cap. Now how do we write it? You know it very well. So we write it in a third bracket. We first write the component of this. We write I cap, j cap, k cap. Then we write the component of this nebula, that is delta x, del x, del y, del z. Then we write the components of V, which are Vx, Vy, and Vz. So what does it basically measures? The curl measures the rotation. Curl measures the rotation of vector field. Okay, and what about the direction? Because you see, curl of a vector is a vector. Previously we defined divergence. Divergence of a vector was a scalar, but here curl of a vector is a vector, so it will definitely have some direction. What is the direction? And the direction of curl vector is the direction of rotation, is along the axis of rotation. Is along the axis of rotation. As you can see in this figure, this represents the direction of curl, that is axis of rotation. Now, as I told you that this curl represents the rotation of vector field. So if you get that the curl is 0, what does it mean? There is no rotation. So if we have curl of some vector equals to 0, then that vector is known as irrotational vector. Irrotational. And obviously if the value of curl is not equals to 0, means it has some rotation, then V will be known as rotational vector. Simple. Now you see, if curl of V is equals to 0, we can write a special thing. We'll talk about it. What about this thing? We can write that V is written as gradient of some scalar function. If curl is 0, we can write that vector function as the gradient of some scalar function. This one is very important. Many a times you will see this, and question may come from this fact also. Now here also we have some vector identities which you should be talking about. The vector identities, firstly, if you have, let's say you are calculating the curl of sum of two vector functions, let's say u and v, then what do you get? It is again distributive in nature. Curl of u plus curl of v, right? And another similar formula which we did in divergence, curl of, let's say the scalar is multiplied u with the vector function v, then it will be u times curl of v plus, so you see this formula are very simple, similar, gradient of u cross v. And if you just compare with these two formula, it has a strange similarity, like strong similarity. U into divergence of v, you see, and here you have u into curl of v, then gradient of u cross v was there, and here you see gradient of u dot v. So if you remember one thing, then from the analogy you can write the other thing. So this formula may be utilized many times. Look, this mathematical method is the fundamental thing. In future you will be studying electromagnetic theory and other subjects as well, mainly electromagnetic theory. In electromagnetic theory these concepts will be heavily used. So if you are not clear here, then you will find electrodynamics very difficult. So if your mathematical part is strong, especially the vector part, then your electrodynamics numerical part will be equally strong. Okay, so somehow try to understand this vector algebra and vector calculus pretty well, so that you find the electrodynamics very easy. Otherwise electrodynamics will hit you hard every time. Okay, let me give you one problem based on this. So this problem came in December 2014, very simple problem. This kind of problem used to come previously. Nowadays also some questions come which are extremely easy. Okay, let R denote the position vector of any point in three-dimensional space. R is the magnitude of R. Then which of the options is correct? How will you solve this problem? So you are given the R vector, which is the position vector. So we can write it as x I cap plus y j cap plus z k cap. So if you evaluate the divergence of this vector R, then this is del x of this function, so that is 1. Okay, so it is like del x by del x plus del y by del y plus del z by del z, thing like this. So this is nothing but 3. And if you calculate curl of R, what does it give you? I cap, j cap, k cap. We write the component of del x, del y, del z. We then write the component of R, x, y, g, and you see this is basically 0. So option D is matching with our answer. Okay, let's move on. Okay, one formula, one or two formula I would like to give you here, important formula. Important note. Number 1, curl of gradient of phi is 0. This is one thing. Mathematically speaking, curl of gradient of phi equals to 0. Second thing, a divergence of curl of A is again 0. Mathematically, divergence of curl of vector A equals to 0. Okay, and here one formula you should keep in mind, like if I give you curl of A, this kind of formula you will encounter in electrodynamics, then this will be written as gradient of divergence of A minus grad square A. Fourth one, this one is an important formula. If you have a constant vector, for a constant vector, let's say A, gradient of A dot R, this value will come out to be A only. And if you take the curl of A cross R, this will give you 2A. This can be proved very easily. There is not an issue. Okay, so let's go for a problem. Look at this problem. If a force F is derivable from a potential function B of R, where R is the distance from the origin of the coordinate system, it follows. Again, this came in GATE 2011. So related problems should be done from all different kinds of exam, different types of exams. F is derivable from a potential function V of R. What does it say? F is derivable from a potential function grad of V. So we know which is F is equals to minus grad V, already we know. Then which of the following is correct? So if this is given, actually F is a derivable function of potential. So if we calculate curl of F, what does it give you? Let's keep minus aside. Curl of grad V. So what is this? Curl of gradient. What did I tell you? Curl of a gradient is 0. So this value will come out to be 0. Means option A is 0. Here we have used the logic that curl of a gradient is 0. So option A is coming out to be correct. Let's move on. A very important calculation is there. Let's say R is the position vector. So how do we write? We write in terms of the position coordinates x, y, z, let's say. So what will be the magnitude? Magnitude will be R. How do we write the magnitude? Root over x square plus y square plus z square. In this way we write. Then we have to show that if you take the gradient of r to the power n, it should give you n r to the power n minus 2 times vector r. So this thing, how will you prove? इसको प्रूफ कैसे करें? Let's go for this proof. So it is like finding gradient of r to the power n. R is the magnitude of this vector r. So we can write it as del x of r to the power n I cap plus del y r to the power n j cap del z r to the power n k cap. Now let's only consider the first one, because the second and third term are similar to first one. So we are dealing with one term first, then using the analogy we can comment on the other two. So del x of r to the power n, if r is equals to this x square plus y square plus z square to the power half. So to the power n means basically it becomes n by 2. And if you take the derivative with respect to x, n by 2 x square plus y square plus z square, this will be n by 2 minus 1, and derivative of x square is 2x. So this gives you nx, and you see what does it give you? It gives you n minus 2 by 2. So can we not write r to the power n minus 2, because r is equals to x square plus y square plus z square to the power half. So this n minus 2 by 2 becomes r to the power n minus 2. So similarly for del y r to the power n, what you gonna get? Ny r to the power n minus 2, and if you calculate del z, what you gonna get? Nz r to the power n minus 2, and hence gradient of r to the power n, this will become, look, they in the first expression sum of these three quantities, and n r to the power n minus 2 is common in each term. First term, what is that? X I cap, plus second term y j cap, third term z k cap. This is nothing but r, so this becomes n r to the power n minus 2, and this is vector r. So in this way we prove that gradient of r to the power n is equals to nr to the power n minus 2 vector r. So you should remember this result. You may require to use this result directly in your examination. So if you remember this result, then that will be good for you. I am giving you a problem similar to this problem. So hold on a moment. Let's try to understand this problem. The expression nabla square r to the power n can be written as. So using the last result, we can easily evaluate, we can easily calculate this result. Grad square r to the power n. So we can write it as divergence of, can write it in this way. This one we have written from this fact that divergence of, let's say, phi a is equals to grad phi dot a plus phi times divergence of a. So using this result, we can write it. And this becomes, you see, divergence of and this result we have already derived in the last slide, nr to the power n minus 2 vector r. So let's directly put that value, n r to the power n minus 2 vector r, nr to the power n minus 2 vector r. Now we can utilize this formula again. Okay, so basically this formula is useful. Now you can imagine that this thing is nothing but the scalar part phi, and this r is this vector a. So let's utilize this. So grad phi dot a, so gradient of n r to the power n minus 2 not r plus phi into, so n r to the power n minus 2 divergence of a, that is divergence of r. Okay, now divergence of this means basically derivative with respect to r. Okay, so n into n minus 2 r to the power n minus 3 r cap dot r plus the gradient, it gives you some vector, so r cap is the direction of this grad of this scalar function, plus, and you see divergence of r we have already calculated the value of divergence of r. This thing has a value 3, so this becomes 3n r to the power n minus 2. So this is nothing but n into n minus 2, and you see r cap is nothing but r by vector r by r. So vector r cap dot r, what will it become? R cap dot r cap, that will be 1. Okay, so this becomes r to the power n minus 2 plus 3n r to the power n minus 2. So it becomes n into n minus 2, so n square minus 2n plus 3n r to the power n minus 2. So n square plus n, that is n into n plus 1 r to the power n minus 2. Is it clear, guys? देखो यहाँ r cap dot r, it becomes r. ये हुआ ना, you can use this identities here and you will get here r to the power minus 3 into r, so r to the power n minus 2. So which option is it matching with? It is matching with option C, n into n plus 1 r to the power n minus 2. So if you remember only one result, this one, you can easily evaluate this one. Let's move on. Okay, this problem, very important problem. Let A, B be two distinct vector, three-dimensional vectors. Then the component of B that is perpendicular to A is given by. How will you solve this? let's first try to draw the vectors. Let's say B vector is this, A vector is this. This is vector B and this is vector A. So for obvious reason, this B vector will have one component here, okay. So B vector will have one parallel component and one perpendicular component. What does the question ask? Then the component of B that is perpendicular to A. So perpendicular to A is this component, you can imagine, or we can say that this is the perpendicular component of B. So if this angle is theta, angle between A and B is theta, so this is nothing but B sin theta, and if I consider the horizontal component, that will be your B cos theta, right. So here we have assumed that A and B are lying on the xy plane. Assume that A and B lie on the xy plane. Therefore, the component of B that is perpendicular to A is nothing but B sin theta. Now if I assign, let's say this is I cap, this is j cap direction, so perpendicular component is j cap direction, right. Now we have to find out like which of these option is equal to this B sin theta j cap. 4 options are given, so which of these options will give us this vector? Okay, let's calculate, like A cross B is there everywhere. In these first two options, A cross B is there or B cross A. So let's find out A cross B, because from A cross B we can easily calculate B cross A. So you know the formula, A B sin theta. Now what about direction? Direction of A is I cap, direction of B is j cap. So direction of A cross B will be A B sin theta, I cap cross k cap, that is k cap. Now if I go one step ahead, A cross B, then it will be AB sin theta multiplied by this A, and direction of A is I cap, direction of A cross B is k cap. So I cross k cap. So I have already told you this, to draw this kind of thing, I cap, j cap and k cap. So if you are taking the cross product of I and k, so we are going anti-clockwise, so that will be minus j cap, right. So this is nothing but minus A square B sin theta, and it is j cap. We need to ultimately find out B sin theta j cap. How can we get this B sin theta j cap from here? First of all, this minus needs to be removed. So if I just write A cross B as B cross A, then extra negative sign will introduce. So this negative sign vanishes, then A square B sin theta j cap. Now to get B sin theta j cap, we need to divide it by A square, and that is why A cross B cross A upon A square is equals to B sin theta j cap, and that is correctly matching with option A. So in this way you can get a solution of this question. So beautiful question came in CSIR-NET examination. That is why practicing previous year questions are very important. It gives you some really standard problems. Okay. So in this video we have covered gradient divergence curl. On the next class we will try to take tomorrow at 8 am. Next class tentatively tomorrow 8 will be covering a linear line integral. That is very important. Line integral, surface integral, volume integral and related theorems. Related theorems, two main theorems are there, divergence and Stokes, and question may come from this divergence and Stokes theorem. These two theorems are very important for your examination. Okay, so we are stopping here today. And guys, before I stop, let me tell you guys, if you are preparing for GATE examination, you can join this GATE 2024 physics test series. So the links are given in the description. And if you are new to this channel, please subscribe the channel and don't forget to press the bell icon and try to attend these classes live, guys, because these classes may not be available for a long time. So it is better if you make a habit of attending these classes live. Okay, thank you very much. See you in the next class. See you tomorrow at 8 am. Thank you.